It's got to look like that. Now let me see if you can come up with one. Find an antiderivative of little f of x equals x to the fifth. Now be careful, because I'm not asking you for the derivative of x to the fifth, am I? If I was to say that, I'd say f prime of x. What's f prime of x? You would say 5x to the fourth. That's not what I'm saying, though. The antiderivative. So basically, I'm saying that is the derivative of something, right? What? You've got to, whatever function it came from had to start with a power of 6, didn't it? Yes? 1/6. 1/6 x to the sixth. I'll talk about the c in a second. Do you see that? So I'm trying to cover up the 1/6. That's kind of weird. I can't cover it up. Imagine that 1/6 isn't there. What's derivative of x to the sixth? 6x to the fifth. So that would give me the x to the fifth, right? But I don't want that 6 in front. So I have to come in with the 1/6 in front of it to kill off the 6 when it comes down, right? Now I could have added any constant I want out here. So how about adding 0, which means don't add anything? That is an antiderivative, right? That's an antiderivative. Now if I were to ask you this instead, find the general antiderivative, then I would want it to look like this. Capital F of x equals 1/6 x to the sixth plus constant. Now that looks, every antiderivative of x to the fifth looks like that. Questions? New page. Find, let's say, antiderivative of f of x equals x to the n. So that's kind of like the x to the fifth a second ago, isn't it? What do we know about the antiderivative's power? What about the power? It's 1 more than that, right? So it's n plus 1. That way when I take the derivative, that power comes down by 1 and becomes an n, right? But how are you going to get rid of the power that's in front? You know what I'm saying? Like the 6, we had to get rid of the 6th by dividing by 6. So what do we put in front of this then? 1 over n plus 1. Good. So if I say take the derivative of that, what you do is you'd bring the n plus 1 out front, right? Which would cancel with the n plus 1. And then you'd reduce the power by 1 and you would get n. Now if we wanted to make this the general antiderivative, we could say plus c, right? Agreed? This is known as the power rule for antiderivatives. Remember, we had the power rule for differentiation, right? Do you remember the power rule when we take derivatives? What's the derivative of x to the n? Nx to the n minus 1. Remember that? Now, this is the rule for going backwards. If you start with an x to the n, and you want to go backwards, you have to do 1 over n plus 1 times x to the n plus 1. Does anybody see a potential problem with this? There is a potential issue here. Go ahead. What's that? Yeah, well, yes. What about, What would cause this thing to not work? What power, what n would make this capital F of x be all messed up? If n was negative 1, right? What if n was negative 1? Then you would have 1 over 0, right, in your formula? So what we have to put on the end of this is if n is not equal to negative 1. So let me look at the case that it is. If n is equal to negative 1, then isn't my original function x to the negative 1? Right? The little f, isn't it x to the negative 1? Isn't that 1 over x? And what is it that we take the derivative of to get 1 over x? The natural log. Right? The derivative of natural log of x is 1 over x. So in the case that n is negative 1, the capital F of x will be equal to natural log of x plus c. So now we've covered it. If n is any number other than negative 1, we use the top one. If n is negative 1, the antiderivative is natural log of x. Okay. You all right with this? We're going to try another example with that in mind. Find the general antiderivative of little f of x equals 1/2 x squared minus 3x to the 7th plus 2 square root of x minus the cube root of x plus 1 over x squared. Let's first write it down, but then let's appreciate that if I was asking you to take the derivative, which is I'm not, right? Could you do this derivative? You would get every power of x, right? You would get all the things in terms of power of x's, and then you would just do derivative power rule on each one, wouldn't you? And you would differentiate term by term, one at a time. No product rule, no power rule, right? No quotient rule, no chain rule here, right? Very, very straightforward. Well, to do antiderivatives, we're going to do the exact same thing. We're going to do antiderivative each one separately. And remember that when we had constants in front, we just leave them when we take derivatives? Same thing applies when you do antiderivatives. So here's what I'm going to do. I'm going to rewrite this function as 1/2 times x to the 2nd minus 3 times x to the 7th plus 2 times x to the 1/2 minus x to the 1/3 plus x to what power? X to the negative 2, right? Now I'm going to highlight where I have constants in front of functions, right? And we're almost looking at this like there's a 1 there and a 1 there, right? So those are all my constants sitting in front of my powers. So let's just focus right now on x squared. What's the antiderivative of x squared? Use the formula that we just got. Careful. Remember the formula is 1 over n plus 1, x to the n plus 1. Right? So n for us for x squared is 2, right? So 1/3 x cubed. Right? 1/3 x cubed. 1/3 x cubed. All right, let's now look at this one right here. What's the antiderivative of x to the 7th? 1 what? 1/8 x to the 8th. All right, now be careful with this one. What's the antiderivative of x to the 1/2? What's 1/2 plus 1? 3/2, right? 1.5 or 3/2. So isn't this 1 over 3/2 x to the 3/2? Isn't it? That's 1 over n plus 1, x to the n plus 1. What's this one? What's 1/3 plus 1? 4/3? 1/3 plus 1 is 4/3? Yes. It is. Yeah, no one. Thank you. You're probably sitting there going, what the hell? What's 1/3 plus 1? 4/3? So this is 1 over 4/3 x to the 4/3. Is that all right? How about this last one? What's -2 plus 1? -1. So we get 1 over -1 x to the -1. Now I'm just going to throw all the numbers in front of these. 1/2, and then I had -3, then I had +2, then I had -1, and then +1. Now, I mean, you get to a point eventually where you can just do all this in your head because you've done it so many times, all right? But just starting out, I'm trying to show as much detail as possible. Let's look at that first one. 1/2 times 1/3 is 1/6. So I've got 1/6 x cubed minus, let's see, 3/8 x to the 8th. What is 1 over 3/2? It's 2/3, isn't it? It's the reciprocal. So this right here is really 2 times 2/3, which is 4/3. So plus 4/3 x to the 3/2 minus, again, 1 over 4/3 is 3/4. So 3/4 x to the 4/3. And then plus, and then -1, so minus 1 over x. Where did 1 over x come from? Nope, not. Careful. What is x to the -1? It's 1 over x, right? Drop it down. Now I'm missing one thing here. I need to call this capital F of x, right? And if it's the general antiderivative, then I need what at the end? Plus c. So that's a good example of a power rule problem for finding antiderivatives. Now, there's some, do everyone have that? I'm going to move on. There's some other functions everyone should just know the antiderivatives of. Like, what's the antiderivative? Find the antiderivative of f of x equals cosine x. So what do you take the derivative of to get cosine? Careful. Is that right? Sure. Take the derivative of capital F. Wouldn't you get negative cosine? So it's just sine, right? The antiderivative of cosine is sine. What about this one? What's the antiderivative of sine? That's negative cosine.